Hey everyone, Mr. Skelton here. Back at it with lesson number 3 in geometry, which is biconditionals and deductive reasoning. And so first thing I want to do is talk about the difference between inductive reasoning, which you did in lesson 1, which was the patterns, right? Like Monday, Tuesday, Wednesday, Thursday. What are the next two things? Friday, Saturday, right? That's inductive reasoning, where you recognize patterns in life and you can make a conjecture or a conclusion about what comes next. So deductive reasoning is similar. You have to use some logic to come up with a conclusion. I'm going to give you a definition for deductive reasoning. What we'd like to say is it's reasoning logically from given statements to form a conclusion. Okay? Reasoning logically from given statements to form a conclusion. Now, you actually do this all the time. People do this all the time. I'm going to just list a couple jobs that people use deductive reasoning. A doctor, right? A doctor, when they're diagnosing an illness, they use deductive reasoning. They're looking for, things that may be wrong. They have a runny nose, they have a fever, they have a stomach ache, therefore they have the flu. Another one would be like a carpenter. Okay. A carpenter uses deductive reasoning. Carpenters do a lot of different things, but let's say they're building a shed, all right, on a house or something like that, or out in the backyard. The carpenter would use deductive reasoning to figure out what materials or tools they would need. Let's say they're building a shed that's got wood siding, and it's got to have 2 doors, and it's got to have a window in it. If that's the specs or what the shed needs, the carpenter would be able to figure out what kind of materials are given. I'll give you the last one here. A student uses deductive reasoning all the time when they come to school, right? Say you have an English paper you got to write, or you have a world history test, or a Spanish exam. You're going to know what you need to bring to class for those things. Maybe your Spanish exam is a Scantron, you need a pencil. Maybe your English exam is on Canvas, so you need your computer. That's using deductive reasoning, right? You're thinking logically, you're reasoning logically from given statements or given situations in life to produce a conclusion, okay? So I have some examples here. The first 2 are examples of deductive reasoning. I'm just going to read them. If you receive 5 tardies, then you will receive 1 ISS. Today you received your 5th tardy. What can you conclude? Well, you're going to ISS for sure, right? You got 5 tardies, so that's deductive reasoning. Second one, if your car battery is dead, you know your car will not start. You test your battery and find that it has no charge. What can you conclude? The car is not going to start. There's no way. Okay. The third example is an example of deductive reasoning that maybe doesn't necessarily follow logic. Okay. Hear me out on this. If a person lives in Springfield, then he or she lives in Illinois. Tammy lives in Springfield. What can you conclude? Now, those of you who are up on your geography, you may know that there are more than one cities named Springfield, right? Springfield, Mass. So this doesn't actually make sense. This is false. This would be a false statement, because Springfield, Massachusetts, she could live there too. So you have to look at the information or the statements to see that they're logically making sense. Okay? So that's deductive reasoning kind of in a nutshell. A lot of you do this all the time. You don't even realize you use deductive reasoning, but you do. All right? Let's jump down into kind of what your homework's going to be more about, which is the second part of the learning target, which is a biconditional statement. And you're going to see a lot of familiar terminology come into play here with conditionals and converses that you learned back in lesson 2. So I'm going to get my pens here. So a biconditional statement, the definition is right here. Okay? A biconditional statement is when a conditional statement and its converse are true. That's important. When the conditional and converse are both true, you can combine them to make what's called a biconditional statement. Okay? Let me show you how this works, and then I'll have you try a couple examples. So here's example one. If two lines are perpendicular, so I'm just going to do this out of habit, right? That's our P. Then they intersect to form right angles. So a quick review on conditional statements. That's your hypothesis, your P, that's your Q. Let's read it again, see if it's true or false. If two lines are perpendicular, then they intersect to form right angles. True or false? It's true. Just put a T there, circle it. Converse. Remember, converse now is where we switch our P and our Q. So if they intersect to form right angles, then the two lines are perpendicular. Kind of writing fast here, all right? So obviously I use my blue pen. There's my Q, and there's my P. Converse, remember, you switch around, all right? Conditional goes P and then Q. You don't have to write this down. This is just review. Converse is Q, then P, right? Those are our forms. That's the symbolic form. Now let's read this again. If they intersect to form a right angle, I'm talking about two lines. If two lines intersect to form a right angle, then they are perpendicular. That is also true. So for a biconditional to work, for you to write a biconditional, this has to happen. You have to have the conditional to be true, and you have to have the converse to be true. In this situation, both the conditional and converse are true, so you can write them as a biconditional. Now a biconditional, here's the nice thing about it. It's basically the conditional statement above, which is this one, with just this phrase, if and only if, in between. So here's what it would look like. I'll write it and then I'll talk about it. I should be using red. Two lines are perpendicular if and only if they intersect to form right angles. Now, you're probably wondering why I wrote if and only if. That's what makes a biconditional statement unique, is right here. You may not have a highlighter, but that's it. Right below it, you see this bullet. You can write a biconditional more concisely by joining the hypothesis and the conclusion with the phrase if and only if. So basically what I did to write a biconditional, you basically just take your exact conditional statement, you get rid of the words if and then. Notice in my biconditional, it does not start with the word if, and you do not see the word then. So that's important, okay? So with a biconditional, there's no if or then in the biconditional statement. You may want to jot that down. So basically, if you look at these two, the conditional and the biconditional, it's the same thing. Two lines are perpendicular. Two lines are perpendicular. Then they intersect to form right angles. They intersect to form right angles. You just put if and only if in the middle. That's how you write a biconditional. Just make sure your conditional and converse are both true. All right? On the back, we have some practice ones here to try. So go ahead and hit pause and try number one and see if you can do that. All right, we're back at it. Let's see if we can knock out this. Oh, I'm off the screen there for you. There's number one. Now you can hit pause and try number one. Sorry. All right, we're back here. And some of these, you'll have to finagle a little bit and try to make them sound nice. And again, there's no perfect way to write some of these. They may differ a little bit, but we'll give it a shot. Let's read the conditional. In the U.S., if it's 4th of July, then it's Independence Day. That is a true statement. If it's the 4th of July, then we call that Independence Day in the United States. So the converse. Let me go back. It is July 4th. That's your P. Right? We don't include the word if. It is Independence Day would be your Q. So that's your conditional statement. Your converse. Now you can write this, like I said, a couple different ways here. I'm going to put this. If it is Independence Day, and I'll put in the U.S., comma, then it is 4th of July. And again, you may not be perfect, write it perfect like me, but it's fine. Let's read it. Let's see if it's true or false. If it is Independence Day in the United States of America, then it is the 4th of July. That is also a true statement. So again, if you're asked to write a biconditional, you need to write the conditional, you need to check the conditional to see if it's true or false. You need to write the converse, see if it's true or false. If one of these were false, by the way, you would just write not possible. You can't write a biconditional if one of these two are false, and that will happen on your homework. You may see that. But since these are both true, now you can combine them as a biconditional. It would read like this. In the U.S., it is July 4th if, I put IFF sometimes for this symbol, that's my shorthand of if and only if and only if it is Independence Day. I'm kind of highlighting my if and only if part like I did on the front so you can see that transition. Remember, biconditional has no if and no then in it. In the U.S., if it is July 4th, if and only if it's Independence Day. Okay? All right, the bottom. May not do all of these, may just do a couple of them to kind of give you an idea what it's going to look like on your homework. So you just got done writing biconditionals. The other part of your homework is going to be like this. They're going to give you a biconditional, like in number 3, and then ask you to break it apart and write the conditional and the converse from that biconditional statement. So here's number 3. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. So the conditional statement, remember, always goes P implies Q. Your converse is always Q implies P. Look at that fancy writing. All right? So you're just trying to pick out what is your hypothesis, what is your P, and what is your Q. Remember that in a biconditional statement, it's just like your conditional. All right? So this is going to be if a number is divisible by 3, then the sum of its digits is divisible by 3. The converse, if the sum of its digits divisible by 3, then a number is divisible by 3. So you're just simply writing the conditional and converse that make up that biconditional, okay? You can go ahead and hit pause and try number 4. We'll stop at number 4. We won't even do number 5. I think you'll get the point after number 4. So go ahead and hit pause, try number 4, and then check back with me. All right, back at it here. So remember, this is a biconditional statement. An angle is right if and only if it measures 90 degrees. So we need to write the conditional. If an angle is right, then it measures 90 degrees. That's the conditional statement. The converse, remember, is Q and then P. So we just switch our blue and red. If an angle, again, this is where you can change it up, how you write it. If an angle measures 90 degrees, then the angle is right. All right, there you go. So if you have any questions, let me know in class. But again, 2 basic themes today in today's lessons. Biconditional statements in deductive reasoning. If you look back at the front there, the deductive reasoning, again, is basically just thinking about how you think, thinking logically with given information. And then biconditional statements, what we talked about, making sure that both the conditional and the converse are true. We didn't do anywhere they were false, right? Every example we did, they were both true, so you could write a biconditional, but you have to be aware that if the conditional or the converse is false, you cannot write a biconditional. So please be aware of that. All right? Take care. We'll see you tomorrow.